Hey, good morning, CP Math 1. This is Mr. Roberts, and today we're going to continue our work with solving systems of equations. And I'm going to add a little wrinkle to this method we've been talking about called substitution, and we're going to continue to work with that. So for this first example, as I look at it, I can see that the second equation does an excellent job of telling me what x is, right? It says, in terms of y, it says, hey, x is the same thing as 7y. That's what x is. So what I'm going to do is I'm going to replace x in the first equation with this value of x. So again, this thing that I'm boxing in green is x, and I'm going to place it right there where x is. So I'm going to rewrite this top equation. It's going to be the opposite of x, but playing the part of x is 7y. So I have the opposite of x. I just wrote that, right? That's the opposite of x plus 3y is the same as 20. Okay, that's the act of substitution. I had an equation with two variables, and it became an equation with just one. Now, this equation is negative 7y plus 3y is 20, or negative 4 times y is 20. That was me just combining the negative 7y and the positive 3y. What I'm going to do now is I'm going to divide both sides by negative 4. And when I divide by negative 4, I get that y is 20 over negative 4, which is the number negative 5. So I now know what y is, right? Y is negative 5. To complete this problem, right, and get my solution, I need to find out what x is. I know that these two lines are going to meet where x is equal to, or y is equal to negative 5. But what about the x? Well, it turns out this the second equation rather says something very nice. It says, hey, x is the same thing as 7 times whatever y is. Well, I just found out y was negative 5. 7 times negative 5 is negative 35. That's what x is. So my solution to this system I write as an ordered pair. An ordered pair is an x value followed by a y value. And the ordered pair is x will be negative 35 and y will be negative 4. So to verify that problem, right, let's run to Desmos. I want to look at Desmos real quick. So in Desmos, I'm going to type the top equation here. It says the opposite of x plus, no, I got to type the opposite. That's interesting. Oh, I know. I'm doing it wrong again. Let's see. Desmos, I have to interact with Desmos. And there's interact. Now I can type. So it's going to be the opposite of x plus 3y's is 20. Okay, there's one. And the other one is 7y is x. All right, so I have I have my graphs, right? And right here I don't see them meeting anywhere, right? But I can tell the way the lines are converging. They're going to meet back here somewhere. So if I zoom out, I can come in here and look at this, right? And I like what Desmos does. It lets me click right where they meet, right where they meet. There we go. They meet when x is negative. They meet when x is negative 5. No, when x is negative 35 and y is negative 5. So my bad, confusion, right? Why is that confusing? Well, because Mr. Roberts, you wrote negative 5 right here. But then when you copied it down, you did this goofy thing of changing it to negative 4. It's not negative 4. It's negative 5. And that's kind of a nice reason why I should look at Desmos, because it helped me correct that error. All right, so let's do our next example. This one is the one that's going to look different than ones that we've done so far, right? This is a little bit more complex. Y is a binomial. That just means that it's something plus something else. It's two things added together. Y is a binomial in this case. And you can see that they're telling me the top equation that this thing that I'm boxing is equivalent to y. Y is the opposite of 7x plus 10. So I'm going to solve this equation by using substitution. I'm going to replace y in the second equation with this thing that's y from the first equation. So here's the act of substitution. That second equation is going to become 3 times x plus 2 times y. But y is a binomial. Y is negative 7x plus 10. So we're definitely going to want to distribute that 2, right, to simplify that. But then on the other side, it equals 9. So please look closely, right? I've got the 3x, 3x. I've got the 2, the 2. I've got the y, but playing the part of y is this thing, right? That's what this is. That's the y. And then I've got the 9 and the 9. So I literally just rewrote the second equation, but instead of using y, the variable, I use an expression that's equivalent to y. So now I can simplify. This is 3x plus 2 times negative 7 is negative 14x. So I can leave it like that. I'm adding a negative 14x. And then 2 times 10 is plus 20, and that equals the number 9. If I combine 3x with negative 14, I'm going to get, this is negative 11x plus 20. 20 equals 9. So you can see real clearly what I did. I just combined the 3x and the negative 14x. If I subtract 20 from both sides, I'm going to get negative 11x is equal to, oh, that's interesting, negative 11. That means that x, if I divide both sides by negative 11, x is just 1. Okay, so I know what x is now. X is the number 1. Y, this top equation tells me. You want to know y? I got y for you. Y is negative 7 times whatever you found x to be. I found x to be 1. And then plus 10. Y is negative 7 plus 10. Y is the number 3. So as an ordered pair is always an x value, comma, y value. My ordered pair is 1, comma, 3. So these two values, or these two equations rather, will meet when x is 1 and y is 3. And I know what you're saying. Mr. Roberts, let's go back to Desmos. Okay, so back at Desmos we go, and we're going to type in the y equals negative 7x plus 10. Enter. Don't see it yet. Let me hit home. There we go. There it is. And the other line is going to be 3x plus 2y. 2y is equal to 9. 3x plus 2y is equal to 9. Enter. And you can see it right there, right? I can zoom in. This is where these two lines meet. They meet when x is 1 and y is 3. Fabulous. All right, let's go look at our last example. For our last example today, it's another system, right? And we're going to use substitution. We're going to be bringing in this binomial, and I can see what I like is in the second equation now, I can see that it's telling me that y is 2x plus 2. So I'm going to substitute that y from the second equation into the first equation. So this first equation will become negative 5x minus 2 times y, but playing the role of y is 2x plus 2, right? So there's my substitution. I just replaced y with 2x plus 2, but that's okay because the second equation tells me that that's the same thing as y. And then that's going to equal negative 40. So using the distributive property here, I'll rewrite this. This is negative 5. Boy, work on your penmanship, Roberts. Negative 5x minus 4x. And I got to be really careful here. I'm distributing this negative 2. So I'm going to multiply negative 2 times positive 2 and get a negative 4. And that equals negative 40. Okay. When I combine negative 5x and negative 4x, that's clearly negative 9x minus 4 equals negative 40. I'm going to add 4 to both sides. So negative 9x is equal to, add 4. Negative 40 plus 4 is negative 36. Don't believe me. I don't believe me. Remember, it's always okay to use a calculator, especially if there's even a momentary pause. So I'm just going to hit, I got a negative 40, and I'm going to add to that a a positive 4, right? I'm adding 4 to both sides. Yeah. And then finally, I'm going to divide both sides by negative 9. So x is negative 36 over negative 9. X is the number 4. 4 times 9 is 36. So I know what x is, right? X is 4. The second equation, right, gives me a beautiful way to figure out what y is. Y is going to be 2 times what I just found x to be. Right, is 2 times 4 plus 2. Y is going to equal 8 plus 2. Y is going to equal the number 10. So now I have both x and y. Y is 10. As an ordered pair, right, as an ordered pair, the solution to this is going to be 4, 10. So these two lines will meet when x is 4 and y is 10. Let's quickly go back to Desmos one last time. At Desmos, we'll go ahead and type in the top equation here. It was negative 5x minus 2y equals negative 40. Ooh, that's off the screen, huh? Hard to see. I'll have to zoom out for that. Oh, there it is, right there. I can see it. And then the other final equation was y is equal to a positive 2x plus 2. I can see there's my y-intercept at 2, and I go up 2 over 1, up 2 over 1. So I can see both. And I can see right here, when I click this, right, I get that, yeah, these two lines meet when x is 4 and y is 10. Isn't it great when we bring things together and we know where that's happening at? That's what happened today. Anyway, so it's a small assignment today. Please make sure you complete it, and I'll see you again soon.